Okay, I'm delighted to be introducing you to Yuan, who's our new research fellow in the Center for Competition Policy. So I hope everyone will say hello to her afterwards, and she's going to be interested in getting to know the group as well. And today, she's going to be talking about some of her work that she's been doing with a local co-author on embracing AI among top R&D investors. So over to Yuan, and we're looking forward to hearing about this.
Thank you very much, Sean. This is the title of this presentation. We haven't finalized the title of the paper yet. Yeah. For those of you who don't know me yet, but I see a lot of familiar faces here. So my name is Yuan Gao, and I joined CCP from September 1st, and before that I've been working at the School of Economics, right in this building, and as a research associate. So I will just directly start with this. Okay, so the overall background, I don't think we need to you need me to go through with you about all these. So the idea is that artificial intelligence has been through several ups and downs. It is new. It is new in the sense that it's like very hot topic at this moment, but also it's not really a new technology. The technologies themselves have been established almost a century ago, and so in this way, it's actually a classic. And in history, it's been through several ups and downs with the technology development itself, and also with the global economic environment. So the current boom that we are witnessing starts from 2011 or 23 or so, and it's driven by the amount of data that we have now to feed into machine learning and the technologies to support more AI functionalities, and also it's closely connected with generative AI, which means a popular demand from more functionalities and applications. So also AI is attracting increasing attention and investment from government, research institutes, and business. Just a few examples. In the UK, we have from 2017 the industry strategy, and then the next year this AI sector deal agreed, and onward. I think in the latest national AI strategy is in 2022. It sets out a 10-year plan, and there are definitely similar activities in the EU, in the US, worldwide. And a few pictures. So this is a picture from the WIPO, which is Worldwide Intellectual Property Organization, WIPO Technology Trend 2019 report, and it shows that there is a boom in AI patent filings, and these are the most significant technology areas.
Sorry, why do you have computer vision seeing numbers and the other improving growth?
Well, this is only in 1 year, I think. It's so I took this picture from the report. It's used to highlight that in just 1 year. This is one of the most fast-growing technology field in that year.
Most importantly, I think the data is from 2013 and 2016.
Yeah.
I don't know how kind of
This
representative.
report was in 2019, and yeah, it's more like a snapshot at that time.
Yeah, one thing that could be done is to bring it also a bit more recent and
Yeah,
use.
that's what I'm going to do.
Okay.
Yes, so this is a literature.
Yeah.
Yes. And so also in same report, it shows that companies represent 26 out of the top 30 top AI patent filing applicants, and only 4 are university or public research organizations. So, and these 5 companies are the top 5. So the question we want to address in this study is, what do companies get from investing in AI innovation? So if we see that so many companies made the majority of the top AI patent applicants, what's there for them to do so? And is it really worth it to invest in AI, and maybe what is the best way to do so? I'm going to skip the literature here, but overall, the literature on this so far puts the benefits for companies to invest in AI innovation in the way of more of a financial way. For example, to look at the company's profits or sales, or from a specific survey, what is their what do companies feel about this? But for us, we want to look at this from what does this do to companies' productivity in their innovation outcome, or just more specifically, we will analyze the relationship between a firm's involvement in AI patenting and its R&D outcome in terms of the total quantity of patent filings. Yep, and our research framework starts from so we focus on patenting activity of the top R&D investors worldwide. There's data showing that I think the top R&D investors in the dataset that I'm going to introduce later is it accounts for over 70 to 80% for all the R&D output in the EU. That's why we want to focus on the top R&D investors. And also, we use a composite definition system to identify AI patents. And then we apply these 2 indices, IRII and NTR, to individual patents. We use these indices to measure the ex-ante novelty in a quantitative way of each individual patent, and then use
We've got a comment or a question online. If Jens brings things up, please.
Sure.
Okay, yeah, thank you. I didn't want to interrupt you. Just a short question. I mean, you're asking what do companies get from investing in AI innovation? And usually I would argue, I would be with you and say, okay, look, counting patents or patent citation is the right way to go forward. But isn't this question be answered very kind of firsthand from the real world that we see today? I mean, so if you have a look at what happens with OpenAI, how much money they get, how much money they make, how much impact they have on policymakers and technology regulation, so on. I mean, so and so that's not only OpenAI. It's not many companies, but it's maybe the top 10 AI companies or so that render, I guess, the outcome variable of patents maybe not so super important. What do you think about this?
Well, yes, I think you're right in that. The thing is, we are looking at the top R&D investors, which are very big companies, and they usually have multiple business operations, and they operate in multiple fields, and not only in AI, and not even only in, for example, computer technology, and we cannot isolate their investment in AI only, and we also cannot isolate their profits in AI only. That's not available to us in data. Does that answer your question?
Yeah, a bit. Maybe we can come back to it later. Okay, thank you. Thank you.
Okay. So yes, then and then with these patent level novelty measures, we can aggregate them at firm level, and then analyze the firm's involvement in AI innovation, and these are the outcome. Okay, so just a brief introduction about IRII and UEA. So these are from our previous work, and they're based on the literature, and the key literature was yeah.
Can I ask you, because I don't fully understand the research question, are you trying to document the trends in the innovation ecosystem, or are you trying to answer some more specific questions?
We do describe the landscape among these top R&D investors in terms of their current performance in AI patenting activities, and just overall, what does AI patents look in the patenting in the whole patent cohort produced by these top R&D investors. So
it's a descriptive paper,
yeah,
and you are focusing on the biggest companies.
Yeah.
So you are not smaller companies that specialize in AI. They are not part of
no, not in this one, not in this one.
Can I ask a related question, actually?
Yeah.
Suppose now, maybe it is true, that the cloud computing is an important, a key component of AI, okay? But none of the company, apart from Microsoft that you listed there, do innovations in the cloud computing.
Mm-hmm.
So what are we missing therefore? If we get, for example, many patents, many citations on something which we're missing a key component there, and therefore you will not even have AI without, for example, the cloud computing. But you don't have, for example, the top innovations on the cloud computing, the top innovations on AI-related patents, which is a different one. So are you telling us a partial story? You have a very broad general question here, but your analysis is very narrow in a way. Isn't it a risk?
Yes, I understand what you mean. So within this paper, we're not looking at, for example, a startup company developing a very new technique. That is not covered in this one. But the same method can be applied to the overall, just looking at all the patents. The reason that we're not showing, but we're not showing that part here is because we're trying to associate patents. We're trying to associate companies with the patents filed by them.
I understand, yeah.
Yeah, so because we're looking at the top R&D investors, so we're only looking at the patents filed by them. But the same method, the IRII and NPR here, they can be used to measure any patent and to monitor just overall the any technological field.
Is the contribution of this paper methodological?
Can I interject to say maybe we could let you, sorry if I've mispronounced your name, can we let you present your paper?
So we had a
No,
column.
but
But
we don't know the question. We don't understand.
Say at the beginning.
We don't understand the question.
It's okay. Top companies to look at the patents that they're filing to see what you can find out from that. I thought the question was.
So I think for people in this room, IRII and NPR are new. So they are methodological contribution of our other work. So I don't want to say that they are the methodological contribution in this work, but we use them in this work. Yes, but the contribution of this work is to apply these methods to provide a picture of what the AI and innovation picture looks like in the top R&D investors. Yeah, so I was just about to enter this. If we have time, I have slides at the end of this one to talk more about IRII and NPR. But the very brief idea is that IRII represents the novelty in recombination. So it is like we are looking at patenting in a specific field, and in this case, it is AI. And we're looking at the AI patents, which technological components they consist. Maybe it consists machine learning, and it consists maybe voice recognition. So these are separate technological components, and we look at how these components may be clustered into natural groups, and we look at how these groups change from year to year. So IRII reflects the intensity of such changes, and the NPR is the new technological ratio. It represents how many. It represents the ratio of new technologies added into the cohort of these collection of technological components in the AI field. So these two indices are at patent level, and I just want to note that IRII is an inverse index, which means the larger the value is, the lower level of recombination intensity a patent has. And ideally, we would want the patent to have a higher level of recombination intensity, to be more, to have a higher level of ex-ante novelty. And we would like a patent to have a higher NER to indicate that it incorporates more new technological components. And the new or old here are referred to the previous year in this study.
Sorry, guys, this is a curiosity. How do you get, if there is a new component of innovations, it will not be there the previous year, how do you account for that? It's just,
It's new.
yes, it's
Yeah.
just the word new, but you wouldn't be able the characteristics. So AI speeching, for example, or something like that, is it a new component?
No.
No.
These are general indexes, not
Okay.
customized for. So data-wise, we use the top corporate R&D investor database. It's released every 2 years, and each release has 2,000 firms, 2,000 top firms investing the largest sum in R&D in the world over a 4-year period. Yeah. So this is not. Ignore these two. This year is wrong. Actually, we have a wider range of data, and it covers patent filed to the top 5 IP offices in the world. And also we added it, we complement it with patent data extracted from the OECD's REPFAT database with some more complete information for AI patent filing. Okay, and then to the AI patent identification, this actually cost us a lot of work, but I don't want to go to the details of it. It's just that this is a composite approach. We use two main literatures. The first one is the patent scope AI index. It's a bundle including it covers AI technique and the functional applications and the application field. So it's not only looking at one way of AI innovation. So for example, it can be the cognitive computer or fuzzy logic, which are techniques. And it can also be applications such as voice recognition or facial recognition. And it can also be application fields like automotive driving, transportation. So another main literature we use is the query method developed by CSET and 1719 Analytics, and it's used for the Stanford AI report. It's similar to, it's actually based on the first one, but it's, I would say, more updated and more accurate for certain fields. And we also combine this with the latest patent classification release. And in terms of query, we look for the above in patent titles and abstracts. Okay, so here are some descriptive. It's just a number of firms among the top 20 investors. filing any patent at all. So some companies might be included as a top R&D firm in the 4 years coverage of these data release, but it doesn't necessarily file any patent. So we first look at this, and the red line here means it's just any firm, and the purple line here means if the firm files any AI patents at all. And I want to know that we also have a category called top 50 AI companies. They are ranked specifically in the 2019 report as the top 50 AI because they have the largest share of AI-related inventions in their patent portfolio. And so this line does not follow the main axis here. It goes in reference to this axis here. So we can see that there is definitely an increase in especially in patents that file any AI patents compared to the overall trend. And in terms of the top 50 AI, they just seem to always be very actively filing patents.
I'm sorry, why do I see a decline from 2019?
Oh, sorry. Yes. I would say that data after 2020 is likely to be affected due to a delay of the patent data updating.
What do you mean?
I mean, some more recent patents might have been filed, but it's not fed into this data release.
Well, if you are saying that they've not been granted but they have been filed, isn't that true for every possible year? That there are some filed and some.
Let's just say that we can. Yeah, I should have cut this picture probably after this. Yes.
Still, you will be asked why there is a decline, though. The decline starts in 2019.
No, I don't think that discrimination is considered in this. They're just looking at filings. So we don't know whether patents actually got passed or granted or not. These are just filing numbers.
Would you expect it to decline after 2019 anyway if the top 50 companies were ranked in 2019? Because the top 50 companies might change since then? Or is that not the case?
We really do not have that data here.
Okay.
Yes. So it is more on the patenting activities.
Okay, I see.
I mean, for a company, it will take certain effort to invest into a certain project in order for it to reach the level of to claim for an IP.
Right.
Yeah.
Thank you.
So also next we look at the number of patent filings. So this is patent number of patents filed by certain companies. So similarly, I think we can ignore this part, and so you can see that also there is a trend of AI patents, basically after starting from 2013. So here we look at the average number of filings per firm. So we have the the bars here, the gray one shows the average filings per firm, and the blue one shows average filings. So this is any type of filings per AI patent filing firms, and the orange one is the average filing per the top 50 AI firms. So we can obviously see that. So we obviously see that AI patent filing firms have a higher average patent output than the average, and then the top 50 AI firm has the highest one. And we can also see that the percentage of AI patent filing firms of all the top 2000 has been increasing over the years. The percentage of AI patents out of all the patents has always been increasing. So this gives us picture of the AI, the activities in AI innovation among these top R&D investors. More and more companies have been getting involved, and we also see the output involving AI technologies. The patents involving AI technologies have been increasing. And so after applying the IRII and NTR indices, we have so this is in terms of different sectors of patents rather than companies. So the sectors here means that we identify a patent into each sector based on the technologies they compose. And we can see that AI in terms of IRII is in the middle. It's not the highest, but it is in the middle. And in terms of NTR, it is also kind of in the middle. And here we're only showing the technologies close to AI. We're not showing the more conventional or more specialized sectors, such as maybe physics or food. We're only looking at semiconductors or computer technology or biotechnology, which is known as a R&D intensive sector as reference. So AI is more overall. AI patents are more have a higher level of recombination intensity than the overall. But in terms of NTR, it is lower.
Can you draw a comparison between pharmaceutical and AI there, for example, in these two metrics? So why are pharmaceuticals higher on this IRII, and then can see the other lower, is it, or higher also for?
So higher IRII indicates that indicates a lower level of recombination intensity. So it is likely that for IRII, the overall level of recombination is low. Or it can also happen when it is a very specialized sector. So it's because IRII looks at the recombination of technological components, and for a very specialized sector, it might just be around the same technological components.
So recombination will be, what is the recombination versus citations? Are the two correlated only or not?
They are correlated
But that's it.
for citations.
Yeah.
And they are correlated. But there is also a very unique sectoral feature feeding into it. Okay. So, and then we look at the descriptive. So when we aggregate IRII and NTR at firm level, this is what we see on time series. So we do not see that they differ much differently, but we do see that in the more recent years, so IRII get closer. And overall, they all go, the IRII goes lower, which means that the level of recombination intensity among the top R&D firms having been increasing. And in terms of NTR, actually we see that the top 50 AI firms have the lowest level of NTR. It's likely because this is a small group of companies, and compared to all the complete sample, they have a smaller field of operation and also innovation. Okay, so in our regression analysis, so we use a linear regression model at firm level where the dependent variable is patent stock, of the number of patent filings of firm C at year T. And the regressors, the main regressors are just the average firm level IRII and NTR indices with 1 year lag. Sorry, I should put, it should be T minus 1 here. And likewise here. And also we use the alternative firm level average indices coupled with the share of AI patents of a firm in that year. It's also with 1 year lag. So it is the so it's this one coupled with for IRII because it's an inverse index. So it's 1 minus AI patent share, and for NTR it's the AI share. And also we use control of firm level net sales, capital expenditure, profits, number of employees, and the R&D expenditure. So R&D expenditure here is the overall R&D expenditure. It's not just for AI. These are all with 1 year lag, and we use a binary dummy, whether or not it's an AI patent filing company, and years. There is also a factor of country. But when not showing the results here, we've done this in robustness check, and it doesn't bring much difference. Okay, so I'm showing the key results here. This is a result using firm level IRII and NTR. And we look at different types of companies. We can see that so IRII, because it's a inverse index, so it's negative, which means a higher level recombination intensity of a patent or of a company's patents overall would have a positive relationship with the company's patent filing numbers. And we see that NTR has a negative, but no significant effect for all companies. And R&D expenditure has a significant positive effect. And for these estimation, AI patent filing as a dummy has a significant effect. And when we're only looking at AI patent filing companies, we do not see anything much significant. But among the non-AI filing companies, we see that these effects are more significant. So also among the top 50 AI firms, we see this is also quite significant. But also NTR is negative. It is also possibly because among these top 50 AI firms, they concentrate on a relatively narrow field. Yeah, and so when we multiply IRII and NTR with AI patent share, we see that particularly the effects are stronger. But among the top 50 AI firms, this is not the case, which is mostly likely because they are defined as top 50 AI companies because they already have a very high percentage of AI patents in their patent portfolio. So the conclusion so far is that so we use this complete AI patent identification method and ex-ante novelty indices to provide a quantitative view of the landscape of innovation in AI among the world's top R&D investors. And our results show that overall having a higher level of ex-ante novelty in its patent filed in the last year, coupled with higher level R&D investment indicate a better chance for a firm to be more productive in R&D output. And the effect is stronger for firms with AI patenting activities and for patents with a higher share of AI patents in its portfolio. This is ongoing work, and we do have future agenda, including we want to look at the firms by the industries they operating in addition to the AI patent sectors. And we also want to expand the landscape that we're watching from the top R&D performers to at patent level to the whole patent collection filed by any types of firm. And at the firm level, we want to also concentrate on the startup companies and on their own startup firms and their patent filings. So yes, these are the main streams of research agendas we are continuing to explore. Yeah, so I think, yeah, that's all for this presentation. And if there's enough time, we can go into more about the IRII and NTR stuff. But so far, this is.
Okay, thank you very much. So maybe one way to describe what you're doing is you've developed a methodology for measurement, and this is an illustration with one sector of how to apply that methodology, which is itself new, right? So that's kind of interesting. I'm very interested in the methodology, and I'll tell you just one thought. A lot of these industries are ones that experience a high level of merger and acquisition activity. And one of my questions is, how does one explain that activity? How does one explain the partnering that goes on between firms? Why did Google buy DeepMind, for example? That would be an AI type of question, and you could ask similar questions for pharmaceutical companies. Why does one pharmaceutical company buy another one? Why, and there are reasons you might want to associate that are anti-competitive. So you might want to bring together a patent group that just makes you unavoidably strong in a certain area. Or you might want to make acquisition. Another reason to make acquisitions would be you're weak in one area of patenting activity, and you know that for negotiations with other firms that you want to be able to have some patents to pull in their area that give you a defense in case they attack you, and also where you can say they violated your patents if they attack you. So I wonder if you can measure some of these things with your methodology, and by somehow, for example, dropping it, you do your recombinative measure with all patents, and then you drop out the patents of an acquiring company and see what the difference is. See if there's if the acquiring company seems to be missing this area of activity. So if you drop out the acquiring company and it doesn't change the recombinative measure, that might suggest it's very weak in that area of patent. Does that make sense as an argument? Does that fit with your methodology?
Yes, yes, absolutely. That is. I mean, overall, these indexes can be applied at patent level and then used to and then associate them to the patent applicants and look at their competence.
So one is a comment on the presentation, perhaps, is, I think it's very important actually that you define these two measures, even because you're applying two measures. I'll give you an example. Suppose that I do an analysis of concentration, I use the HHI, and I go and present it from the humanities crowd, and I say, I'm using the HHI, and the result is this one. It's very important that you find an easy way to explain this is what this metric is, so that people can understand that concept, move on to the next one. Okay, so that is doesn't matter, it's not we understood from your description, but do show it. It's very important for your
Yes, because really we have a whole paper.
Yeah, but you cannot expect us to know your paper.
Yeah, I understand that.
So that's also a comment on the presentation, so don't take it, it's not important. If I take these your results now, my worry is that what is on the right-hand side seems that everything is endogenous there, and by lagging them one period, you say, oh, it's exogenous now, perhaps because if you want to take place before, so we can look at the effect now. So maybe there is a way to do that. Maybe you're right, but think about this now. What is happening is, coming back to my example before, forget about the AI for a second. Suppose that you're looking on innovation on the automobiles, and you do search some words on the automobiles, and you say, I look at the characteristic of the cars, to see the patents that relate to this characteristic, and altogether they make these good called automobiles, okay? And you have them all. You got all the information, all of them, but you don't have somehow the information on fuel. Fuel is not there in your data, okay? Now you ask the value what's the value of a car if there is no fuel, Actually, what's the value of a car if there is fuel, okay? It's different, The question, the reason I'm coming to this one is, when you search for AI and these kind of things, there are important aspects that, you know, they create the value of AI, but they're not counted in your dependent variable there, but they do contribute a lot on that's why you get a growth on the dependent variable. They're very omitted in your independent variable. If you're lucky, they don't even correlate with your variables here, but I don't think so. If they do so, you have a risk of endogeneity here and identification. So you need to have a way to think, you know, outside the box into that, because if you present in this regression as your main story, you might suffer of the part, you know, this is a complicated product. It comes as a bundle of other things. Yeah, I'm controlling one of them, but there is so much of the growth coming in from other things that are so important and possibly correlated with the right-hand side variable. That's one thing. Second, your left-hand side variable, which is the patent stocks. If you go back on the figures that we saw earlier on, we struggled there because it takes some time to file the patent. It might not be in the data set. So it might be okay because you do a sub-period of analysis here. So you're making sure that you don't get the right-hand side when there is missing information. Suppose now after using all the information up to 2022, whatever it was there, and then suppose that your data up to 2022 or 3, then now your dependent variable is suffering a selection that is there, and therefore is also biasing your analysis as well.
Yeah,
I have a third comment, and I'll finish after this technical aspect. In your last regression, you're looking at the share. You can look at the share, but never put an interaction between two variables without also adding the two variables separate. Okay, because again, you're producing an effect which is not true. You need to put the two variables and the interaction, then you do the analysis of that. Thank you.
Yeah, no, I think you make a very good point here. Yes. Yeah, I completely agree. Yes.
How do you account for, so correct me if I'm wrong, but the data you've got is from 5 different patent offices. How do you account for companies that have filed a patent for the same thing in different jurisdictions?
Well, we count each patent filings rather than patent families.
Okay.
So yes, but these apply for all, and I mean these are top R&D investors. So they mostly have global operations. Most of them do file to multiple national offices.
Okay, so they're all filing across all the offices anyway, or expected to generally file at multiple offices. Okay.
Yeah.
I just have some suggestions, but mostly it would be to a little bit clarify the research question that you have. From what I could see from your presentation, the last slide, etc., it seems to me that you have two very different research questions that are conflated in the same paper. On the one hand, you want to map the AI innovation ecosystem, the trends in patenting for large firms. That's fine. And the second research question, you are looking at patent novelty and what is the effect of previous patent novelty or the ability to produce novel patent on R&D productivity. These, for me, are two very different questions that deserve two very different papers.
One is more descriptive and the other is more...
There is tons of work to do on both.
Yes.
Okay? On the innovation ecosystem, I would say, if I can make a little suggestion, Warwick, they recently got a huge grant. I was in London last year. They had a wonderful conference with DeepMind, government officials, etc., because they are mapping the AI innovation ecosystem in the UK. So that's very interesting. There are tons of other papers that already do your job. So you should know these papers that they have been published. I've contributed a little bit to that literature myself. So that's one thing. If you look at the effects of novelty on R&D productivity and value, there are tons of papers on that as well. Something that I would suggest that you have a look at is have a look at a paper that I was the reviewer of that, building on the shoulders of science. They do something different from you. They look at how close to science patents are, and they explore a number of different channels, the most important of which I was referring that paper quite a bit ago. It's the value of patents. There are tons of data sets that you can use to impute value to patents, and that would be important. When I listen to your discussion, I would like to know the novelty. Is it important to create value? Because novelty just for the sake of it could be completely useless. I'm not convinced from your analysis that novelty is important. Having a little bit of validation for that assumption within your data set.
So
would be
actually,
better.
as you said, there are a lot of literature on the value of novelty, on patent novelty themselves, and actually our previous work was also contributing to that. And we also have analysis supporting the value reflected by the indices that we're using. So yes, it would be clearer if I incorporated that into the literature shown here.
Thank you.
I met the author of the paper was complaining about the reviewer. No, I know.
Okay, so I think we're formally done with our session right now. It's 2 o'clock. But I would propose, I see you had these other slides at the end, and it might be, some of us might be interested to learn a bit more about your methods. So maybe you could, we can take a break and let people go. But and thanks so much for coming, Karen. Great to see you. And maybe you could keep going with some of those other slides you have, and we can, yeah, we could keep this open too.
So it's the idea of IRII and TR is based on the patent cohort of as a network. So here I'm using an example, pseudo examples, for example. So just for those of you, I doubt you are all very familiar with this. But, so we're using the technological components defined by the IPC classification system, and so each IPC classification code is a technological node. And the IPC itself is a hierarchy structure with from the section to subclass level to subgroup level. So we are looking at IPC at subclass level as a technological code. And if two subclasses are assigned to a same patent, then we would say that there is a connection between these two nodes. And so in the indices themselves, we actually calculate the density of the nodes at subgroup level. So under each subclass, there are several numbers of subgroups, and we will look at how many subgroups are connected, and then we will use that as the weight or density of the connection between the two nodes. And then in terms of a patent cohort in the same period of time, we will aggregate all these weights between any two different nodes. So this will provide us with a network where there are a number of technological nodes and
Is this a neural networks method that you're using? Is a neural network this method? And you can put the weights on every connected the links.
it is similar to a neural network, but we so the network construction is like this. We identify the natural clusters formed by these nodes and the connections using the Markov chain method.
Sorry, can I ask you the clusters that are based on keywords and words? Because you're starting by reading the abstract of the patent, okay, which is a certain number of words. In principle, are you using those words to define the clusters, or are you using the definition given already by the, if you want, the patent? The words, exactly. So those are creating the clusters, and once you have that, you can say, how do I link patent 1 to patent 2, once we have identified that there are similarities in terms of clusters, and then link between them, you can put same ways to the two of them. So there is some way that you're putting into that cluster, depending on how
we're
likely
actually
you're...
looking at how does a patent how does the patent how is the patent written by using different elements from using technological elements from different clusters in the previous time period, in the reference time period. So that provides us with IRII. So that's the idea of IRII. Yes, so this is the clustering stage. And then, so this IRII is the degree to which the grouping of a patent's technological components represents a novel way of recombining these subclasses compared to their mode of usage in the preceding cohort of patent application. Yeah, so this is likely to be the definition that you would like to see.
Please understand.
Yes, it just yeah. So you can see that the sentence itself is a mouthful. Yes.
But can I link this to breakthrough innovation versus incremental innovation in a way? Because if it is a breakthrough innovation, it's something which is completely new. So could be completely set of new words in your case. The abstract is this new versus the other one, the 80% of the words of this period are the same in the previous one.
So I think there is a paper by OECD. It lists out a group of conventional or more recognized patent quality indicators, and one of them is breakthrough. So breakthrough in that report, by their definition, is top 1% or top 5% of patents ranked by their Ford citation numbers. So in our previous work, we ran regression using breakthrough, and to show that the IRII is negatively or the recombination intensity is positively related to breakthrough. Okay. And the NTR is relatively simple. It's just that whether or not in a patent there is any new technological component compared to the whole patent cohort in the previous time period. It's just so one thing is about how much recombination is there. Another thing is about how much new things are there. Yes. So yeah, this is an example of the naturally identified clusters in a patent cohort.
And a cluster is a set of words. Cluster in your case is a collection of words that was in the description of the patent.
Yeah. Yeah, so this is an example when we were studying the pharmaceutical industry in the year 2005.
But it is,
So, yeah, that's
could you define the word cluster?
Yeah, I think the way to start, if I were you now, I will take a patent, I will get, as an example, I say, so this is the description of this patent one. These are, say, 100 words that describe the patents, for example. Now, I have, if you want, a language processing method in order to take these words and put into combining together to define one cluster. Is this, because that's what you're doing, isn't it?
I think she's taking the IPC classification.
Does it say no, I thought?
no, so the clusters are a group of technological
Keywords.
a group of IPC classes that are more closely connected to each other in a certain patent cohort.
Yeah, so you don't need to know the abstract of the patent to get that.
No, so these are the technological classifications.
That's disruptive saying, yeah.
Yeah. So this is not a language analysis. This
It's
is
not.
not a text search. No, it's not keyword. It's the classification code.
It's the one that's already done there, basically.
Yeah. Yeah, so that's a brief idea about these indexes.
Very good. Thank you very much, Juan. It's been great to hear about it.